Hello everyone, so today I'll be discussing question number 30 of GATE 2014 Set 1. Mathematical idealization of a crane has 3 bars with their vertices arranged as shown in the figure. With a load of 80 kN hanging vertically, the coordinates of the vertices are given in parentheses. The force in the member FQR will be. So here's the member FQR. So we need to determine the force in this member FQR. 4 options are given to us. It's a 2 marks question. And for this type of problems, you can refer to lecture series on Structural Analysis 1 by Professor Amit Shaw, Department of Civil Engineering, IIT Kharagpur. Let's start with the solution of this problem. So we will use the method of joints to find the force in member QR. Okay, so first of all, let us find out the reactions due to this applied load 80 kN. So at joint Q, there will be one reaction which is, let's say it's VQ. At R, we will have 2 reactions. Let's call it VR, and one horizontal which is HR, since it was a hinged joint. Okay. Now after marking these reactions, we will use the equilibrium equations to find out the value of these reactions. To find out the reaction VQ, let's take the moment about point R and summation of moment to be 0. So this is one equilibrium equation which we will be using. When we will take the moment about point R, the forces are VQ multiplied by the distance QR, which is 2, and there will be another force. There is another force which is 80, but it is in opposite direction to this VQ, so it will be 80 multiplied by 3, and no other force is there, and then equal to 0. Okay, from here we will get the value of VQ as 120 kN. So now we get the value of this VQ reaction. Now to find out VR, we will use another equilibrium equation. Let's say summation of force in vertical direction to be 0. So let's write down all the forces which are in vertical direction. So we have this VQ which is upward, so let's call it positive here, plus we have VR plus VR, and we have this 80 which is in downward direction. So let's write minus 80 equal to 0. From here we get the value of VR as minus 40 kN. Now we get the value of VQ and VR. Now we have another reaction HR. So let's calculate that this also. For calculating the value of HR, we will again use the equilibrium equation. We will take moment about point P, summation of moment about point P, and put it to 0. Let's take the moment about this point P. So let's mark the forces again: HR, VR, and VQ. So we will have VQ multiplied by distance between this P and line of action of this force VQ. This distance is 1 meter. So we'll write 1, plus we have another force VR. Both VQ and VR force are trying to rotate this about this point and trying to rotate it in anti-clockwise direction. So we have taken same sign for that. If you want to take anti-clockwise to be positive, we can do that also. Multiplied by distance between point P and line of action of this point force VR, and this entire distance is 3. We have another force HR, and this force HR is also trying to rotate this in anti-clockwise direction. So plus HR multiplied by distance between this point P and line of action of this force. This distance is 4, right? So 4 equal to 0. Now we will put the value of VQ. The value of VQ is 120 multiplied by 1, plus we have VR. VR we got as minus 40. So let's write minus 40 here, multiplied by 3 plus 4 times of HR equal to 0. From here we get the value of HR as 0. 120 minus 120, 0. So now we get the value of all the three reactions, VQ, VR and HR. Now let's find out the force FQR. For that, let's draw this joint R separately here. So we have this joint R, we have the force F PR here, and let's FQR. So initially I am considering every force to be tensile in nature. Okay, so I have drawn the tensile force. Let's draw the reactions also. So here we have one reaction at R, which is VR, which we just calculated, which is minus 40 kilonewton. Minus 40 kilonewton means it is opposite to what we have assumed. So initially we assumed it to be in upward direction, so it is actually in downward direction. So it is 40 kilonewton. We also have HR, value of HR is 0. So we do not have any force here in horizontal direction. So let's satisfy the horizontal equilibrium here for this joint R. So this is joint R. So summation of force in horizontal direction to be 0. So what are all the forces in horizontal direction? We have FQR plus FPR, this let's call it theta, cos theta equal to 0, because no other force is there in horizontal direction. So the value of theta is given to us as 53.13 degree. So let's put it here, FQR plus FPR cos 53.13 degrees equal to 0. Let's call it equation number 1. Let's satisfy the vertical equilibrium as well. So we can write as F, or we can write a summation of force in vertical direction to be 0 for joint R. For this we have FPR sin theta, FPR sin theta. We have another force which is 40, but it is in downward direction. So minus 40 equal to 0. From here we get the value of FPR as 40 divided by sine 53.13 degrees, and FPR we got as 50 kilonewton. So we got the value of FPR as well. Now we know FPR, we know F. So now we have to find FQR. We can use this equation 1 from here. So from here we can get the value of FQR. So let's put the value of FPR in equation number 1. So from here we get the value of FQR as minus FPR minus FPR cos 53.13 degrees. From here we get the value of FQR as minus 30 kilonewton. So since I have initially assumed every force to be tensile in nature, and I am getting the value of FQR as minus 30 kilonewton, it means that force in member QR is compressive. So we get our answer that the force in member FQR will be 30 kilonewton and compressive. So answer will be option number A.